Problem 9. I need to find out value of load resistance which is connected across A and B. So here is that resistance RL, and also I need to calculate the maximum power at load. Here I will use the maximum power transfer theorem. So this is the same circuit to calculate open circuit voltage. Before calculating it, I simplified the circuit a little bit, considering this and these 2 points, and left side of this point I applied Thevenin's theorem. When I apply Thevenin's theorem, then VTH will be voltage across this 20 ohm resistance. In that case, this 2 ohm is flowing through this 20 ohm. So 2 multiplied by 20, that will be 40 voltage, that is the VTH, this one. Or will be RTH at this circuit. This current source will be open, so 20 ohm resistance is RTH. So this is RTH. So this portion of the circuit has been converted into a voltage source and a single resistance by using Thevenin. The rest part of the circuit are same. So ultimately I got this circuit which is equivalent of this left hand circuit. Now to find out this VOC, this is open circuit voltage. The open circuit voltage, this VOC is potential at point A with respect to this point. So this is equivalent of this voltage source and voltage drop combination. If the current through this 20 ohm is flowing in this direction, then potential drop will be, this will be positive and this will be negative. So what will be VOC? VOC is this potential drop minus of this one, because these have been opposite polarity. This is plus minus, this is minus plus. So potential drop across this minus of 10 volt is open circuit voltage. So this one. So to get the potential drop across this 20 ohm resistance, what I need to calculate current through this 20 ohm. This current will flow because of this 10 volt and 40 volt. These 2 sources are there in this loop, and the resistance is 20 and 20. So current will be the combination of these 2 voltages. This is plus 40 volt, this is minus 10 volt. So total voltage is 40 minus 10. This 40 minus 10 volt divided by full path resistance, that is 20 plus 20. This is the current flowing through this 20 ohm resistance. So that will be multiplied by this 20 ohm is ultimately potential drop across this 20 ohm resistance. Through this calculation, ultimately I got VOC is 15 volt. Now to calculate RTH, this is the main circuit, this is the position for RL. This voltage source, that will be shorted, and the current source, this will be open. So ultimately this is resistance combination to get RTH. It is very clear that here 20 ohm and 20 ohm are in parallel. If we start walking in this direction, we get 2 paths. One is 20 ohm, another is 20 ohm. Ultimately these 2 paths meet at a particular point here. So this 20 and 20 are in parallel. After this parallel calculation, I got RTH is 10 ohm. So using equivalent circuit, this part is Thevenin equivalent. RTH is 10 ohm, VTH is 15 volt. To get maximum power at load, value of load resistance will be equal to this RTH. So it is 10 ohm. By using this maximum power formula, I got it is 5.62 watt. Now checking whether my calculation is okay or not. This equivalent circuit with VTH 15 volt, RTH 10, and load resistance is same with that 10 ohm. Same load resistance has been used here in the main circuit. Now the power at load in main circuit and power at load in equivalent circuit, if these 2 are same and value of it equals to 5.62 watt, then it will be confirmed that my calculation is perfect. So running the simulation, say in equivalent circuit is showing power at load is 5.62 watt, and in main circuit power at load is 5.62 watt. So whatever the calculation I have done here, everything is correct.